Okay, so welcome everybody. Okay, so hello, welcome everybody to this this is the last TA session of this particular course for this week. I hope I'm audible. Can somebody please confirm?
Yes.
Yes,
Yeah,
sir.
yeah.
You are audible.
Yes.
Okay. Yeah, so the way we have been asked to conduct this particular sessions are as follows is as follows. Like, we will take some questions which were given as part of last year's assignment, and we are supposed to solve that in this time. So that is what I'll start with doing. And if you have any questions in between, or if you have any questions, general questions about the course, some small things which can be discussed, then after going through the questions, you can ask me. I will try to solve them. Today will be the first, it will be based on the first week, so it will be a very basic, the first part of the course will be the part that I'll cover today will be basic introduction. So okay, so I'll get started with it. So I'll start with a series of questions. So as you can see, I hope you can see my screen as well. So okay, so let's start. So as you might be knowing that okay, so there can be machine learning problems can be of several types. So they can be supervised learning problems, there can be unsupervised learning problems, there can be reinforcement learning problems. The first question, or the first so the first question is regarding that. My screen is also visible to all of you, right?
Yes.
Yeah. Okay, so the first question that is given is like, which of the following are supervised learning problems? And the four options are given: learning to drive using a reward signal, predicting disease from blood sample, and grouping students in the same class based on similar features, and face recognition to unlock your phone. So these are the four options, and multiple may be correct. Let's go one by one. Is the first question, the first option, learning to drive using a reward signal, can that be considered as a supervised learning problem?
Reinforcement.
It's a reinforcement learning problem.
Reinforcement learning.
Yeah. Yes. So it's okay. This is creating some issues. So it's too big. So the first one is a reinforcement. Somebody still joining. Reinforcement learning problem, or RL problem. What about the second one, predicting disease from blood sample?
Supervised learning.
Supervised learning.
Okay. So I would go ahead and ask one further question. So it is a supervised learning problem, that is correct. So can everybody please put themselves on mute? Yeah. I would ask one more question, like, predicting disease from blood sample is a supervised learning problem. But can you say anything more about it? Like, is it a classification problem? Is it a regression problem?
It's a classification problem.
Correct. Okay, so this is a supervised and
Learning.
a classification problem. Correct. So what about the third option, grouping students in the same class based on similar features? Your voice is very feeble, whoever is answering.
So that's a clustering problem, isn't
It's
it?
a clustering problem, yes. Okay, so it's an unsupervised problem. That's fine. And finally, face recognition to unlock your phone.
supervisor learning.
Supervised.
It's a supervised. So okay, so I'll just tick the correct options here. So the second option and the last option, these two are the supervised learning problems. So this is, yeah, as I told that this would be quite simple. So which of the following, this coming to the next question. Okay, so the first question, I hope nobody has any doubts because you only answered it. So I'm moving on to the second question. So in the second question now, it's about classification and something else. So which of the following is our classification problem? So the first one, predict the runs that a cricketer will score. Is it a classification problem?
It's a
No.
regression.
No, sir.
Regression.
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 It's a regression problem. Correct. The second one, predict which team will win the tournament.
Classification.
So it's a classification problem. Predict whether it will rain today
Classification.
Classification.
and predict your mood tomorrow.
Classification.
Classification.
Correct. Okay, so you guys are answering, so I'm not explaining this much more. So if anybody has any issues with any of these questions, you can stop and ask me at any point of time.
Hi, could you explain why the D option is a classification? Couldn't it have multiple options as well?
Which one? The D option, right? I mean, predict your mood tomorrow. Yeah, so predict your mood, you can think of an use case like predicting your emotion, predicting your mood. So you can be either angry, happy, sad, neutral, you can be surprised. So you have categorical labels. So whenever you have several options from which you will have to select one or more, it is a classification problem.
Got it, yeah.
Okay. Okay, so now the next question is the exact opposite of that. Which of the following is a regression task? So predict the price of a house 10 years after it is constructed. So
Regression.
it's a regression problem. And predict if a house will be standing 50 years after it is constructed.
Again regression.
Okay.
Regression, sir.
Predict if a house will be standing 50 years after it is
Acha,
constructed.
house. Okay, it's not a price.
Ah,
Classification.
okay, yes. So okay, so oh sorry, this will be no, right? Yeah, then predict the weight of food wasted in a restaurant during next month.
Again regression, sir.
It will be regression. And predict the sales of a new Apple product.
Sales. Again regression.
Okay. Now which of the following is an unsupervised learning task? Multiple options may be correct as always. The first one, group audio files based on language of the speakers. What do you think is it unsupervised or is
Is
it
it clustering or unsupervised learning?
clustering is a type of unsupervised learning, that is correct.
Yes, sir.
So the first one is unsupervised according to you.
It is supervised. Based on language, right?
Right, and somebody said unsupervised, somebody said supervised. Okay, so this is basically a an unsupervised task, because you see the reason why you can call this to be an unsupervised task is if you are asked to group audio files based on the language of speakers, then and you are given the language of the speakers themselves, then that you actually have no task to do. I mean, you have been given the language of the speakers and you are asking a set of audio files to be grouped accordingly. So you won't need machine learning for that. You will just write some code and it will group it accordingly. Correct? Am I making sense? Hello?
Yes, sir.
Yeah, so if you are asked to group audio files based on the language of the speakers, you will have to assume that the language of the speakers is not given to you, and therefore this becomes an unsupervised learning task. Okay, so this becomes an unsupervised learning task. Again, group applicants to a university based on their nationality for the same reason. This, yeah,
Unsupervised.
yeah. Predict a student's performance in the final exam.
Supervised.
This will be
Supervised
supervised. Okay. And predict the trajectory of a meteorite.
Sup-
Yeah, that will also be supervised. So the first two options are unsupervised learning tasks.
So
Okay.
I have a doubt regarding question 4, option D.
Yeah, predict the trajectory of a meteorite.
Yes, sir.
Yeah. Yeah, you see that so predict the trajectory of a meteorite is, you can think of this similar to you have been given the what should I say? Okay, so you have been given a time series. So this is so this is the meteorite path that was given to you, and now depending on this path you are predicting the path of the meteorite in the future. So you are using the information that was given to you to predict the future, and therefore this becomes a supervised learning task. Okay.
Thank you, sir.
Yeah. So then we have a small problem like given below. We have a data set. You are using KNN regression with k equal to 3, which means that you will take the 3 nearest neighbors and you will take a mean of them, and that will be the value of your output for the point that is given to you. So okay, so the best way is to so Euclidean distance is given. So the best way would be to draw the diagram, draw all these points and then figure out which is the closest point to 3, 2. 3, 2 is the test point. I have circled it now. So the one thing is you can find out the distances between for all of them, and you can do that, is also fine, and generally you would need to do that if it's not 2-dimensional. But here, since it's 2-dimensional, I'll just try to draw and figure out which are the points which are closest to 3, 2. So let's see. Okay, so this is 1, this is 2, this is 3, this is, oh, we have to add 6 here as well, 4 and 5. Hope they're equidistant so that I can just have a look. And okay, so the first point is 2, 5, which is lying approximately here. That is the first point. The second point is 5, 5, which is lying approximately here. The third point is 3, 3. Okay. Then 6, 3. Then 2, 2. And 4, 1. So these are the 6 points which are given, and we have to find the 3 nearest points to 3, 2. So let's plot 3, 2. I'll plot it in a different color. 3, 2 is this somewhere. This is huge anyway. Okay, so 3, 2 is this particular point. So you can understand that again okay, this okay, so this point and this point. These are the three closest points. Am I correct? I mean, is this making sense?
Yes, sir.
Yes, sir.
Yeah, so what are these 3 points? The first point is 1 comma 4, so 4 comma 1, which is this point. Then I have 2 comma 2, which is this point, and then I have 3 comma 3, which is this point. So you take a average of 3 plus 2 plus 2.5 by 3, and that will come out to be 2.5, 7.5 by 3. So the answer would be 2.5. okay, so that is clear for everybody.
Yes,
Yes,
sir.
sir.
Yeah. Okay, so coming to the next problem again, which of the following is a reinforcement learning task now? Learning to drive a cycle, learning to predict stock prices, learning to play
In
chess.
the last question, sir.
Huh? Yeah.
Sir, in the last question,
Yeah.
all the points you got the mean value 2.5.
Yes. Yes.
It is given Euclidean distance.
Yeah. Yeah.
So Euclidean distance is something like root under x1 ka square, x2
Yes.
minus
Yes.
x2 ka square.
Yes. 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 Correct. So see, the reason, use Euclidean distance measure for finding the closest points, which means that you have to take the target point and find out the Euclidean distance for all these 6 candidate points. Okay.
Yes.
So you can do that. You can do that and check for all the 6 points. But whenever it's a 2-dimensional thing, you can just draw. And I mean, from the diagram itself, this was clear that these 3 points are the closest. But you can go ahead and check all the 3 points, and you can check the distance between 3, 2 and all these points, and you will get the same answer by that also. These 3 points will turn out to be the closest.
Okay, sir.
Yeah, so if you want, I can do that also maybe. Okay, so let me do that. I mean, it was a bit of a, I mean, this was easy, that's why I did it in that way. Okay, so let me do it like this. So 3 2 is my target point, and let me take all the points one by one. I will not take the square root, I will take this I will take the squared distance. So square root anyway will be this, I mean, the order will be preserved anyway. So for the first one, the distance between 3 2 and 2 5 would be 1 plus 3 square, right, which is root over 10. Then for between 3 2 and 5 5, the distance would be 4 plus 9, which is root over 13. Then for 3 3, the distance would be, the first one is 0, the second one is 1, which is root over 1. Okay, then 6 3, it is 3, okay, it is 3 2, so it will be 9 plus 1, which is root over 10. The next point is 2 2. Okay, so that is again 1. The next point, the final point is 4 1, which is 1 plus 1, which is 2. So if you see here, by this calculation, by the Euclidean distance calculation, root 1 and root 2, these 3 are the closest points, which is 3 3, 2 2 and 4 1, and these are the points that we just visually we could look at the graph and we could see that indeed these 3 are the closest points. Clear now?
Yes, sir.
Yeah, okay, so yeah,
How the average distance is calculated?
okay, so for KNN regression, what you need to do is you will need to find the 3 closest points as k equal to 3 here. See, k equal to 3 is mentioned. So you will take the 3 closest points, you will just take the values of y for these 3 points and just average them out. Okay? Yeah. Okay, so then comes which of the following is a reinforcement learning task? Multiple options again may be correct. So learning to drive a cycle, is it a reinforcement learning task?
Yes.
Yes.
Yes. Yes.
Okay, learning to predict stock prices.
Yes, sir.
Okay, so I will put a question mark here. Learning to play chess
Yes.
Yes.
Yes, sir.
and learning to predict spam labels for emails. And okay, so the first, okay, so reinforcement learning is a sort of a learning mechanism. You will be taught this much later, I believe. So reinforcement learning is a sort of learning mechanism where you go ahead and you do something. You don't know whether, for example, when you are learning a bicycle, so you first go ahead and try to cycle and you fall off the cycle, and some environment or the world tells you that what you have done is not correct. Okay, so reinforcement learning has that sort of a flavor in itself. Like when you so learning to drive a cycle, when you are learning to drive a cycle, you will learn only by trial and error, right? And therefore learning to drive a cycle is a reinforcement learning task. Similarly, learning to play chess is also a reinforcement learning task, because you will at one let's say you are at the penultimate move of the game, and you make a move, and because of that move you lose the game, and from the next time onwards, when you are at that same point, you will never make that move, and you are learning by trial and error, and therefore learning to play chess is also a reinforcement learning task. However, learning to predict stock prices is a regression task. You are predicting the price of the stock price based on what the stock value was of a particular stock, what the stock value was on the previous day, and therefore learning to predict stock prices cannot be a reinforcement learning task. There is no trial and error involved. It's not like you will predict the stock price today and you are wrong, then you are again given the option of predicting the stock price today. That will never happen, and therefore learning to predict stock prices is not a reinforcement learning task. And learning to predict spam labels for emails is a classification task. I believe that is clear by now. So A and C, these are the two options which are reinforcement learning tasks. Is that fine?
Sir, last option D, how can we reinforcement?
Last option D is not reinforcement learning task. That's what I was saying. It's a supervised classification task. Okay.
Yes, sir.
Okay, so the next question is find the mean of the squared error for the given predictions. So y is the actual value and fx is what you have predicted, so you need to find out the mean of the error. Okay, so this will be very easy. You see, so how you need to calculate this is y minus fx whole square, and whatever number of examples you have, I equal to 1 to n by 1 by n. N is the number of examples that you have, so n equal to 6 in this case. So here it will be like 1 by 6, and the summation would be 2 minus 1 whole square plus the first one would lead to 2 minus 1 whole square, the second one would be 3 minus 2 whole square, 5 minus 4 whole square, and so on. So everything is 1. So so the answer would be 1. Okay, is it fine?
Yes, sir.
Yeah. Okay, so the next question is find the mean of 0 1 loss for the given predictions. So if you're what does that mean by 0 1 loss? Like if you have predicted correctly, then it will be 1, and if you have predicted mean of the 0 1 loss, okay, so if you have predicted correctly, then it would be 0, and if you have predicted 1, if you have predicted incorrectly, it will be 1 because you will account for that. So the first case you have predicted correctly, so it will be 0. The second you have predicted incorrectly, so it will be 1. Third 0, third will be 1, fourth one will be 0, this one would be 1, and this one would be 0. So you can understand that the answer would be 3 by 6, so 0.5. Okay. Okay, so coming to the final two questions, we have the definition of bias and variance. So bias is basically how can you say, okay, so let's say this was the predicted, this was the true something that you wanted, so true line that you wanted to predict. Let's just talk about lines now, so because that then it is clearer. So if you are this, if this is the true line that you wanted to predict, and you ended up predicting something else, like you ended up predicting this, you ended up predicting something like this, this is your prediction. Okay, so this is a case. Okay, so okay, maybe not, I'll not show this, I'll show this in the next question maybe. Okay, this just talks about the definition of bias and variance, so it doesn't make sense. Okay, so bias is nothing but, so the first thing is bias, because what it will say is, okay, f hat x, okay, what it is saying is fx, yeah, okay, yeah. So the first is indeed the definition of bias, and the second one, okay, yeah, and the second one is the definition of variance. Okay, so I'll talk about this in a figure, and then probably it will become more clearer. So right now you just think that bias, so how can you decide on the bias and variance? So variance, first of all, is like this. So suppose if this is your prediction, output, if this is your prediction, what you have predicted, and you take a mean of all your predicted output. So this line is basically the mean of your predicted output, let's say. So this becomes E of f hat x, this becomes E of f hat x, and so the variance of your predicted outputs across this mean output, so the variance of your prediction is nothing but the variance of the is what is defined by variance. Okay, and am I making sense?
Please explain again.
Yeah, okay, so let me try to draw it like this. Suppose you are predicting something, so right now don't think about what your true prediction was supposed to be, but this is the output that you have generated. Okay, so this becomes your f hat x, this is your predicted output, and now what you need to do is you need to find a mean of your predicted output. So the mean is given by expectation of f hat x. Okay, so this straight line, here is your expectation of f hat x. So variance, if you variance of any random variable can be denoted as E of x minus expectation of x whole square. Okay, so just replace x by f hat x, and this becomes f hat x minus expectation of f hat x whole square, and that becomes your variance. Okay, you see, so the minus sign doesn't matter because there is a square. So expectation of f at x minus f at x whole square, that becomes your variance. Okay, is it clear now? The definition of variance, is it clear now?
No, sir.
Okay, so can you tell me where you are having doubts?
Can I explain the variance? The theory explain the
Your
variance.
voice is not clear for some reason.
So how I can explain bias and variance?
Bias I'll okay, theoretically you will have to explain it like okay, so theoretically you will explain it like if your input changes very slightly. So for example, since this is your predicted thing, so suppose your input is changing from let's say from here x to x plus delta x, it's changing only slightly, right? X plus delta x is changing only slightly, but your output is changing a lot. Is this understandable now? So if your input changes by a small amount but your output changes a lot because of that, then that means that you have you are in a high variance state. Your model has reached a region of very high variance where a small change in the input is leading to a huge change in the output. Okay. And bias, so by the term bias, so it's quite what should I say, it's very similar to the term bias in English, which means that you are heavily biased about something. So bias means your model is so biased about its own about something that even after seeing a lot of training data, it is not being able to understand, it is not being able to predict the test data at all.
Soumya,
Yeah.
may I offer a suggestion?
Yeah. Hello.
Chat. I think that will actually help clarify the difference between bias and variance.
I could not hear you properly. So
I've sent the link to an image in the chat. So
okay.
if you could open that up, that might help in the explanation.
Let me see. This is high-low bias. Yeah, this is a. I mean, this would be. I feel that this might be a bit more because this is nothing else is written here. So this might be a bit more confusing. So let me. Yeah.
Essentially, bias is just how far away from the actual answer, and variability is like how concentrated it is to any answer.
Yes, so that is from a classification point of view. So bias, okay, so let me, what was I saying? Yeah, okay, so let's say bias, so your belief is so strong that even after seeing training data, you are not learning anything. Okay, so that means you are heavily biased towards your previous belief, and so this problem of high bias is also known as underfitting. Underfitting means you are not being able to learn the training data itself. So that is also known as underfitting. And variance is the exact opposite of that. Variance is you have learnt, your model is so complex. Your model is so complex that you have learnt everything that was to learn in the training data, and because of that you have learnt very complex very complex lines or graphs, whatever. So like this, so your graphs would be varying like this. Okay, so this, and if you can, and if you compute the variance of this particular line, the variance of this particular line would be very high, because it is moving far away from the mean on both sides. The mean is this particular line. Okay, and that problem is known as overfitting problem. So high variance is overfitting, and high bias is underfitting. Is that clear now?
Yes, sir.
Okay, so the final question is again on bias and variance. So complex models tend to have high bias. Okay, so can anybody answer whether complex models will have high bias or not?
High variance.
Complex models will have high variance, and they will.
It can also be possible it can have high bias.
Low bias.
Low bias.
Why will it have high bias? See, bias, as I told, that your belief is so strong that even after seeing training data you are not learning anything. So if your model is very complicated, you will be able to learn the training data at least very well, and therefore complex models can never have a high bias issue. Okay, I mean, of course complexity is a relative term here, but complex models generally tend to have low bias. They won't they would learn very well the training data, but maybe they will not generalize well to the testing data. Okay, so complex models tend to have low bias. Okay, somebody has raised a hand. Yeah, you can go ahead with the question.
Sir, can you give more a theoretical definition about variance?
Okay, so f hat x, this is your prediction. Okay, expectation of f hat x is the mean of your prediction, and expectation of f hat x minus expectation f hat x whole square is the definition of variance. Is that fine?
Sir, I asked for a theoretical definition.
Yeah, this is the theoretical definition, right? I mean,
No, sir, not like that. I was asking that, like bias, you said that how well it can distinguish how strong it's about the output. So like that, is there some definition about variance?
yeah, so variance, I mean, are you asking from a practical point of view? I mean,
Yes.
Okay, so variance you would understand like when you train your model, when you train a machine learning model, if your training accuracy is, let's say, what, 95%, and your testing accuracy you won't see, you will see the validation accuracy. So validation accuracy is, let's say, 50%. So that means you are in a high variance region and your model has memorized the training data completely. Okay, so so that is the practical way in which you can understand variance. I mean, you will understand variance when you train deep learning models or machine learning models. The other way is, let's say you have these training points. Okay, let's say you have these training points and you can fit two graphs to this, two lines through this. So one line would be pass through all this. Okay, one line would be to pass through all this. Okay, the other way would be to pass through this. This is another line that you can pass, that you can fit. Okay, so this, in this case you might think that okay, the curvy line may not be that bad, but let's say you have this particular case, you have one point here, you have one point here. Okay, so I hope the points are visible. So now if you try to draw a line through all these points, so suppose your model is very complex and it has been able to memorize all these points properly. So this is the line that will get fit. Okay, is it clear till now?
Yes, sir, I got it.
Yeah. So now if you see these points, these 2 points for which your line became this curvy may actually be outliers. They may not even be correct points. There might have been some noise in the measurement, and because of that these points have gone here and here, I mean here and here, and therefore you will not, I mean in the test data you might not face any outliers. You might face a point which is you might be asked to predict a point which is lying here. This might be your test data, this might be your test time point that is given to you, and based on this line you will predict something else. You will know that, okay, let's say that you will be, so definitely you will not be predicting a correct value for this particular point because your curve has gone up like this. Okay, so yeah, so that is the way you can think of bias. So bias, sorry, variance. So variance means you have a high, okay, variance means high train accuracy and low validation accuracy, and this is high variance, and high bias means you have low training accuracy. So if you have low training accuracy, then of course you will have low validation accuracy also, so that goes without saying. Yeah, so that is about bias and variance.
Okay, sir.
Yeah. Okay, so these are the 10 questions. So apart from this, any more questions that you have, anybody of you might have, you can ask me now.
Sir, I have one question.
Yeah.
Sir, how to overcome this high bias and high variance to have ideal model?
Okay, so that is there is something known as bias variance trade-off. So I will talk about that maybe. Okay.
Sure, sir.
Yeah. So bias variance trade-off. See, the reason why you have a high bias in your system is that the main reason for that is your model is not strong enough. So bias means high bias. So whenever I am writing bias means that means high bias. I am not writing it again and again. So model is weak to model the training data. Is this line clear to you? That why is bias coming? Correct. Okay. So model is very weak to model the training data. It is not learning anything from the training data. So what do you think can be the way to overcome this problem? So you need
Add more data, like new data.
Okay, so see.
Machine learning is going on, na?
Yeah.
Change the assumptions.
Assumptions. Okay, so the first suggestion was to increase the training data. Why that won't work is, see, if you are modeling, if you have 100 examples, 100 training samples, and you are not able to learn from the 100 training samples, and then you go ahead and increase 900 more training samples to make it 1000 training samples, it won't be able to learn from the 1000 also, right? I mean, if it is not being able to learn from 100, you can't expect it to learn from 1000.
So
Yeah.
Just a question, like how the model become complex?
Yes. So
Like
yeah.
in theory, sir, like what is a simple model and what is a complex model?
Okay, so this is way ahead into the course, but you can think of like, have you heard the term neural network?
Yeah, NLP.
Not NLP. NLP is natural language processing. MLP, did you say? ML?
Answer.
There is, okay, so there is something known as MLP. I think you said MLP. So,
N for
no, M. NLP is a different subject, and MLP is multi-layer perceptron. Okay, so this will be taught to you later in the course. So what you have is, so I'll just give a brief overview of how these things work. Okay, so let's say these are inputs. You have three-dimensional inputs. You have this is known as hidden layer, and this is known as the output, and all these will be connected by weights. Okay, everything is connected, so I will not draw because otherwise it will become very, okay, I'll draw maybe. And these are your outputs. So these are the inputs and these are the outputs. Okay, this got, okay. So the way this works is like, this is a one hidden layer MLP. Now you can go ahead and do like this. This is one way in which you can you can think of your model like this. The other way you can think of your model is like this. You can have one more layer of MLP, one more hidden layer in between, and you can connect this like I had connected the top one. You can connect everything, all the nodes in the second MLP also. So this is a two hidden layer MLP. And this is a more complex model than the first one. Okay, is the model complexity clear now?
yes.
Yeah, so for this is for neural networks. For others like SVMs, you can start changing the kernels and then your model will become more complex. But generally when we talk about all these things, we talk about neural networks, and therefore neural networks, you can think that if you increase the number of hidden layers, that means you're increasing the complexity of the model. Okay. Yeah, so that is the, okay, so what was I saying? Yeah, so the model is weak to learn to model the training data.
Sir,
So yeah,
sir, the sampling of the sampling for the training data should be unbiased and should be evenly collected from the population.
yeah, so the question that you are asking is very it's a very good question, but that is not the reason for bias variance trade-off. Okay, so what you are saying, let us discuss about that a bit more after I discuss about bias variance trade-off. Is that fine?
Okay.
Yeah. Okay, so one question is like you see, okay, so what was I saying? Yeah, model is very weak to model the training data. So let's say your model is this one layer hidden MLP, one hidden layer MLP, and you are trying to model some, you are trying to learn from some data, and the model is, and the training loss is just not coming down. So if you have this model and with your training data the training loss was not coming down, if you increase the training data, it won't come down again. I mean, it won't magically come down, right? It is impossible for this data, it is impossible for this MLP or this neural network to learn the data that you are providing it that you are providing. However, if you increase the model complexity, right, if you increase the number of hidden layers in a neural network, maybe it will start learning the data a bit more. So the way you can get rid of bias is to increase the model complexity. Is this point clear?
Sir, I have a question.
Yeah.
Sir, does the model complexity also depend on the number of epochs while training the model?
Generally no.
Okay, so sir, like while we increase the number of epochs, then the training accuracy and the validation accuracy increases.
That means that, see, when you are training neural networks, your model is having multiple looks at your data. So it is not like you pass the data only once and your model will learn everything, because this is a very there is a learning algorithm called backpropagation. So that also you will be taught later. So the backpropagation algorithm goes ahead and changes all these lines that I am talking. These are nothing but some weights, some values. So all these values are taught to the neural network by backpropagation, and therefore the backpropagation algorithm, for it to work properly, it needs to learn the data, it needs to look at the data multiple times. Okay. And therefore as you increase the number of epochs, the training accuracy goes on increasing, and validation accuracy also increases if your model is not overfitting.
Okay, sir.
Yeah, and then if you train your model for extremely long periods of time, what it will do is it will just look at the training data and it will start memorizing the training data again. Okay, there is a very celebrated theorem, like this neural network can approximate this 2-layer neural network. I think it is true for 1-layer neural network also, but I am not sure. But definitely for this 2-layer neural network, it can approximate any function that is out there in the world. So if you use your training data sufficiently long to train this neural network, it will completely memorize all your training data. And so that is the way you go ahead and train your data. But you need to train, I mean, there are certain things that you need to notice in the training and the validation accuracy to when to stop training. So is your basic doubt clear?
Yes, sir.
Okay.
So once it memorizes the data, that means later on we won't be able to learn more things from it. It will be like same thing going on.
Yeah, so I did not want to go into all of this now. So see, what happens is you will have training data, you will have validation data, and you have test data. So these are the 3 data splits that you generally create in a machine learning problem. So you train on your training data, okay, and you have the option of training it forever. How many number of epochs you want, you can train on your training data, but you will look at the validation data to understand when you need to stop training. So when your validation accuracy stops improving, that is the point where you stop training. Okay, is that fine?
Yes.
And this validation data is generally, I mean not generally, is never used to train your model. Your model just sees the training data, and so as you said, when you are seeing the training data, there is a risk of your model memorizing the training data completely. So that is why you continuously test on an unseen data set, and where that comes from the validation data. So when the performance of your model, which is performing very well on your training data, is quite good on the validation data and it's continuously improving, you will continue training on the training data. But training data, when it continues, training accuracy will always increase with the number of epochs, but validation accuracy is either decreasing or is remaining constant. That is when you need to stop training your model. You save the model at that point and then directly run on test data. Okay.
Sir, how come it is related to model complexity then? If in case I am increasing the model complexity, then my variance will increase.
Yeah,
Point
precisely.
Training data and the test data accuracy should match.
Yeah, so precisely. So what you just said is the reason why this thing is called a trade-off. So if you need to reduce the bias, you need to increase the model complexity, but as you increase the model complexity, your training data accuracy, I mean the variance of your model will start increasing, and therefore your test data accuracy will come down. And that is why this is always a trade-off, and that is why you need this validation data to understand when you need to reduce your model complexity or when you should not increase your model complexity any further. Okay.
There is the role of error or the loss function in this trade-off.
Loss function error,
Do we need to minimize the errors?
you always need to minimize the error, that goes without question. So whatever loss function you have chosen is given to you. Let's say the loss function also is given to you, and you are looking at the training loss and the validation loss. Training loss is continuously decreasing, but after, let's say you had thought of training your model for 1000 epochs, and after 600 epoch you see that your training accuracy is going on increasing, but your validation accuracy or validation loss is not reducing anymore from 600 to 650. You look for 50 such epochs, and whenever and see that your validation loss has not improved for 50 epochs, that is when you stop training your model. Okay.
Yes, sir. Get it. And same case goes for high bias and low variance.
High bias and low variance, of course, yes. High bias is generally something that you would find from the training data itself. Your training accuracy will itself not increase, or training loss will not reduce. But yeah, you can look at validation also. I mean, it's highly it is not possible that your training accuracy is not improving but your validation accuracy is improving. That is not possible.
Okay, sir.
Okay, so one more question that somebody asked me was about the bias in the data. So that is a different question altogether. So this is a bias variance trade-off, which is like much related to the model complexity, and bias is something which you need to, I mean, it is a thing that
What is bias, sir?
Huh?
What is bias?
Yeah, bias is this thing which I told, right? Like your model is when you are implementing a machine learning model, if your training loss doesn't reduce or your training accuracy doesn't reduce over a number of epochs, that means your model is very weak. You need to increase the complexity of your model. Increasing the complexity means maybe adding one more hidden layer to your neural network. Okay, so that is a high bias that your model is having, when your model is not being able to reduce the training loss also. Okay, I hope I made it clear. Yeah, and the bias that somebody else was talking about was related to the dataset bias. Now that is something which is a ongoing research topic in machine learning right now. So that is a different sort of a bias, and there are, I mean, very few methods, not very few, there have been some methods recently which have been able to find out what sort of biases exist in our data sets. Like you will find one very famous example that nurses are generally always females and doctors are always doctors are always male and nurses are always females. So that is a bias that all machine learning models will generally learn. Then there are many such other things. So that is it's a very interesting research topic, and but that is not related to this bias variance trade-off right now. Okay, so yeah. Okay, so
could you please explain the difference between validation dataset and test dataset?
Okay, I don't know whether has this been taught in class as of yet, or are you yet to hear these terms? Are you hearing these terms for the first time?
As of week 2, no.
Okay, so then you will be taught this much later, but since I have introduced this already, so let me just tell, like generally the standard notion is you have so your data, you will divide it into 70%, 15%, 15%. So this 17, 15, 15 are just, I thought of them, that's why I wrote. I mean, of course this is the training data and this is the maximum. The other two you can make it 80, 10, 10 or 70, 70, 10, 20, whatever. So let's say your test data is given to you. So in that case, this 15% vanishes. So let's just say test data is given to you, so you don't need to worry about test data, but you have training data and test data. So from the training data, what you will do is you will make it 80% and 20%. This 80% you will use for training your model, and this 20% you will think of as a validation data. Now what is validation data? You see, testing data is generally should not be available to you. I mean, ethically you shouldn't have test data. Therefore, however, for example, you will have many such things. You will learn this as you go along, like you will have the number of epochs, the thing that I have already mentioned, the number of epochs for which you train your model, the learning rate of your machine learning optimization model. So, and there are many other things. Okay, again, number of hidden layers in the neural network. These are all design decisions that you will have to make. Now, let's say you didn't have the validation data and test data is not available to you, so you just have the training data. So how will you decide when to stop training? Because as you go on with the number of epochs, your training accuracy will go on increasing, and finally you will end up with a model which is heavily overfitted to the training data, which cannot generalize well to the test data. So in order to decide on all these parameters, so these are also known as hyperparameters. So in order to decide on all these hyperparameters, you will require a data set which is not test data, but which is unseen. Which is unseen in the sense that your model is not seeing that data and updating its weights accordingly. And that is the role of validation data. So all these things will be fixed based on the performance on your validation data. Okay? Is this clear now?
So, but the model has also not seen the test data, no? So why is there a another need for validation data? Isn't test data itself enough?
Okay, so let's say you are a machine learning practitioner and you have training data and test data is with the client. Okay, this is a normal setting. This is a setting that you are comfortable with, right?
Yes, yes.
And client has given you a lot of data to train on, and the test data is something that the client will give at the end of your machine learning model development. How will you understand whether your model is heavily overfitted to your training data and cannot generalize well to any unseen data set with just the training data that is in your hand?
Got it, sir.
So the validation data, in the absence of test data, validation data serves as a proxy for the test data. Okay, so that is why this validation data is important, to set up all these hyperparameters so that your model development goes on well. Of course, one thing which you said is correct. Your validation data itself might not be similar to the final test data that your model is tested on, but that is something that you can't help.
So,
yeah.
Sir, as validation accuracy increases, can we stop the training data set?
Validation accuracy, when it stops, can you come again? What did you say? When it stops increasing, is it?
Sir, like when validation accuracy increases, can we stop training the data set?
No, when validation accuracy goes on increasing, that means your model is performing well on unseen data. Okay, and therefore you should continue training your model at that point. Only when your validation accuracy stops increasing, at that point you should stop training your data. Okay.
Okay, sir, it's clear.
Yeah. Okay, so any more questions?
Yes, sir.
Yeah.
Sir, like in the upcoming time, can we also make the model? Like, will be there any practical sessions?
You will have to ask the TAs. For us, NPTEL has strictly suggested to stick to the questions and solve these questions. Maybe I'll see. I mean, let's see in the coming today. I mean, I don't think there is any need for any practical session, but if the need arises, then I will definitely, maybe I'll schedule one practical session for you guys. let me see how it goes on. Okay.
Okay, sir. Yes, sir.
Yeah.
So one question, like there were 3 slots, you were taking all those 3 slots?
No, there are 4 slots. One is on, I will be taking this slot every time, every week, Saturday 7 to 9. There are 3 more slots, I think. Friday there is some slot, and Saturday there are 2 more slots, 3 to 5 and 5 to 7. Those are different PMRF scholars. So I will be taking only this one.
Sir, every session has same questions.
Huh? I did not.
Sir, every session has same questions.
I think so. Yeah, that is the way NPTEL has designed this thing. So you can. So the option is up to you. You can attend any one of the courses, any one of the sessions. You don't need to attend all the sessions.
Thank you so much.
Yeah.
Okay, sir.
Yeah, so can we have the recording as I have the recordings of this will be updated. I mean, I will give the link to NPTEL, and NPTEL I think will make it available to you. And for WhatsApp and the group is not there, and so yeah, is a recording of the session. I'm not able to. Okay, somebody is saying he or she is not able to hear anything. So I think it's a bit late. Okay, is there a WhatsApp group? I have okay. Yes, sir, in assignment 1 can we have 2 probability related questions? Can we discuss similar questions? It will be really helpful as I'm not from CS or IT background. I'm not supposed to discuss the present assignment, so I can't help you with that. Present assignment, they have strictly asked us not to discuss. What type of question in exam, that you can post in the forum of NPTEL course, and somebody will answer, because we are not the original TAs for this course. There are more TAs who will be taking the exam, and they will be handling those modalities. Okay, I don't see any other. Okay, which book is best for this course? Okay, that's a difficult thing to answer. It depends on how much mathematical exposure you have. If you have very strong mathematical exposure, then you can go for a book by Bishop. I forgot his first name, Chris Bishop or something maybe. Yeah, you can go for Bishop. Bishop is a good book. So pattern recognition and machine learning. And there is another book by what was this guy's name? There was another book, I'm forgetting the name right now, but Bishop is a good book. You can search Bishop machine learning and it will come up. So yeah, Bishop you can try.
So could you please share this notebook, maybe convert this into PDF or
Yeah. I will right now I am still writing, so I will need to figure out how to convert this to a PDF. What I'll do is I'll convert this to a PDF and I will put it in Google Drive, and I'll give the link to NPTEL, and NPTEL will then share it with you guys. And let me know if you are not getting the links from the course webpage. Then from next day onwards I will share the previous day's PDF files with you all in the chat in the beginning of the next day's lecture. Okay, so I don't think there are any more questions.
Samir, there are some of the questions, I believe the options in the assignment, I think some of them are incorrect, because for example, week 2 non-graded assignment, the first question we have the same option repeated twice. So
in the assignment, in the present assignment, is it?
in week 2.
Okay, okay. Then
So week 2, the practice, and not even the actual assignment, even in the practice assignment, sometimes we have the options are incorrect.
okay, then I would, yeah, you please write this in the forum, because we can't change the assignments. That is something that the TAs do. So you post this in the forum and attract their attention and ask them to change the options. Okay.
All right.
Yeah.
Sure. Okay.
Yeah.
Fine. I think I also mentioned before that it would be helpful if underneath each video, if they could give us a link to find additional information or some kind of extra study material, that would be helpful.
For each video.
Yeah. So in each video, if like they could give like some extra like reference material or some supplementary material, that would be helpful, because most of what is being taught essentially is kind of far out of the field kind of thing. So for example, the multivariate regression that we did, it was not just multivariate regression, it was multivariate regression through successive orthonormalization.
Okay.
So for us, but the video names are just multivariate regression. So if you end up searching for just that, you don't get the entire topic that is discussed in those pictures, in those lectures. So if directly there are some supplementary material that is provided right underneath the videos, that would be very helpful. If not, like even if it's a section wise kind of thing, like say, okay, week 1 follow like we are following this book, this section to this section. Week 2 we are following this section, something like that. It would be a little bit more helpful.
Okay, so I really don't know how to, because you see we don't have access to these videos, okay, and we can't change these videos. So I would suggest again the same thing, like all these sort of problems you can post in the forum, and maybe the TAs who are assigned to this course, they will be able to tell you more about this. Whatever. So from next day onwards again, so see the questions that I handled today, they were pretty basic. I don't know whether we need any book for this, but from the next day onwards, if the topics are such that you would require some reference material to look at in order to understand it better, I would definitely put it in this PDF, and this PDF will anyway given to you, so you all, and therefore you can check that particular link which I will be referring to. Okay, so I'll do that from the next. Today I think was simple, so I didn't put any material.
No, that's fine.
Yeah.
Just wanted to like bring this up.
Yeah,
I think there have been some discussions in our the discussion forums also. I think somebody did ask for additional study material, and I think there was a reply given.
Okay.
I don't remember exactly what it was, but there was like, I think like even some support. I'm not saying that it's not, but it is very difficult to like put all of it together. It's like, okay, like which section in which book, in which part of it do I follow for this particular understanding. So that's the thing. Others, it becomes a little bit difficult when there are 4 or 5 different books and you're looking for a specific topic and you end up having to like look through so many books just to find, say, 1 paragraph, 2 paragraphs. So it's just to make that part easier.
Okay. Yeah. Okay, so any more questions? How about Machine Learning by Tom Mischel? Yeah, definitely you can go for that book also. I have not gone through that book, so I don't know how complex it is, but you can look at it. Yeah, Machine Learning, there is a book, or I think there is a lecture series also online available by Tom Mischel. Okay, so if there are no more questions, I'll close the session for today, and we'll meet again next Saturday, same time, 7 o'clock.
So will we be getting the recording of this one?
Yeah. I will post this to YouTube, and you will get the YouTube link from that.
Okay, thank you so much.
Okay, yeah. Thank you.
Thank you, sir.
Thank you, sir.
Thank you so much, sir.